So in this video, we are going to continue solving our problems from exercise 10.1. In the previous video, we saw problem number 1. Now we are going to go to problem number 2. So let's read out the problem. It reads, let me zoom in now. Yes. Okay. So write true or false, give reasons for your answers. So we are given a set of 6 statements and we have to see if each of the statement is true or false and we have to justify our answers. So let's start with the statement number 1. Line segment joining the center to any point on the circle is radius of the circle. Okay, I'm going to highlight the key points here. So center to any point on the circle. Okay, that's a key point. So that is a very definition of radius. Okay, just to quickly visualize the statement. So if this is your circle, okay, this is the center of the circle. So a line segment that joins the center, okay, so this is the center, okay, this is the center, let's call it O, okay, to any point on the circle. So we can take any point on the circle, this point, this point, this point, this point, this point, and we can connect these line segments, okay, like this, like this, oops, so like this line segments, okay, all these line segments are going to be the radius of the circle. That is the very definition of the radius of the circle. It is a line segment which joins or which starts from the center of the circle to any point on the circle. So this statement is, I'm going to mark it as true. And let's erase this. Yes, let's erase this as well. Okay. Now let's go to statement number 2. Yes. Statement number 2 reads, a circle has only finite number of equal chords. Okay, so first let's understand what is the chord. First let's understand what is the chord in the circle. So if this is a circle, once again I'll draw a bigger circle. Okay, and let this be the center of the circle. Let's call it O. Okay, what is the chord of a circle? A chord of a circle is a line which connects any two points on the circle. So I've taken any two random points on the circle. Let's call them P and let's call this Q. So chord is nothing but a line segment which connects P to Q. Okay. So yeah. So this is our chord. Now they are talking about not any random chord. This is a keyword. They are talking about equal chords. Okay. What do you mean by equal chords? A chord which has equal length, or the length of two different chords should be same. For example, let's consider another set of points. Okay, let's say, okay, let's call this X and let's call this Y. Okay, so this is also a chord, so I'm going to connect X to Y. This is also a chord. Okay, then let's take another set of chords here. This is a small chord. Okay, so let's call this A. Okay, let's call this A. Let's call this A and B. Okay, so here you can see we have different chords in the same circle, but their lengths are also different. Okay, very clearly this AB is shorter than XY. Okay, now they are talking about equal chords. So what will be an equal chord? So what we can do is, okay, in order to find equal chord, let's keep it and I'll draw a different circle. Okay, so let's draw a different circle here. Yes, so this is another circle with the center here O. Okay, now consider this chord. So this is in fact a diameter. Okay, okay, the length of this chord is equal to twice the radius. So I'm going to just draw it again. Yes. Okay, why is it coming? Huh. Okay, now consider this another chord which also passes through the center of the circle, and consider this another chord which also passes through the center of the circle. Can we say all these three chords are equal in length? Are they equal chords? Yes. Why? Because they are all diameters, and diameter of a circle has a constant length. Now the statement reads, a circle has only finite number of equal chords. Is that true? Does this circle have finite number of diameters? Absolutely not. The circle, any circle always has infinite number of diameters. Okay, you can draw infinite number of diameters passing through the center of the circle. So the statement that a circle has only finite number of equal chords will be false. So let's mark it false. So statement number 2 is false. And what is the, we have to also give reasons for our answer. So what is the justification? The justification is a circle has, okay, so let's try to zoom out. A circle has infinite number of diameters, okay, which is also a chord. So yes, that is the justification. Now let's erase this and go, okay, let's erase this also. Now let's go to statement number 3. Okay, this is our statement number 3. Let's try to zoom in. Yes. Now a circle is divided into 3 equal arcs if a circle is divided into 3 equal arcs, each is a major arc. So this again comes down to visualization, how well you can visualize this problem. So let's say this is a circle, okay, and this is the center of the circle. Now they want to divide the circle into, let me highlight it, 3 equal arcs. Okay, we want to divide the circle into 3 equal arcs. In that case, each is a major arc. So we will not have a major arc and a minor arc. All the three will be an equal arcs. Is that possible? Yes, that is very much possible. Why? And how are we going to do it? So this you can see, I mean, a circle will have a 360-degree angle. So if you want to divide it into 3 equal parts, we have to make each arc of angle 120 degree. Okay, which means, so I'm going to try to do it. How are we going to do that 120 degree? So yes, so this is 180 degree, right? This is 180 degree. So 120 will be a little bit less than that. So something like this. So yes, let me do something like this. Okay, so this is our 120 degree. Okay, now this part is again remaining, and this also has to be 120 degree. So let's try to construct another similar arc. So let's try to think from this way. So this is again 180. So 120 will be something like this here. So I'm going to draw like this. Okay, this also is one, sorry, this also is our one, this also is our 120 degree arc, and this also is our 120 degree arc. Okay, so as you can clearly see, each arc, let me use the highlighter here, this is one arc, okay, this is another arc, okay, and this is our third arc. Three major arcs, and all three are equal in length. If you try to visualize this, it's like a pizza. Look at this. It's like a pizza which is divided into 3 equal parts. So if a circle is divided into 3 equal arcs, so we have 3 equal arcs here, okay, each is a major arc. This is a true statement. So I'm going to just mark it true. We are not going to have one major, one minor. All three will be major arcs. All three will be in fact equal in their size. So yes, and the justification is, this is how you justify, by giving a visual explanation. Now let's again erase this and go to statement number 4. Statement number 4. So before I move to statement number 4, just to revise what's happening in all these statements is they are challenging, or they are testing your basic definitions and basic knowledge about the properties of the circle and the terms related to the circle. Okay, so you can see in each statement they're either talking about the chord, or they're talking about an arc, or they're talking about a segment, they're talking about radius, they're talking about diameters. So all these very basic but very important terms we have nicely understood and explained in the previous videos. Do revise them if there is any confusion, and then keep again solving these questions. So let's go to question number 4 now. A chord of a circle which is twice as long as radius is a diameter of the circle. Once again, this is checking the basic definitions of radius and diameter. We all know that diameter, length of the diameter, so I'm going to just write it here. We all know that the length of the diameter is always 2 times the length of its radius. Okay, so this number is very important. 2. The length of the diameter is always 2 times the radius. So if there is a chord in a circle and it is twice, so let's highlight this, it is twice as its radius, then it will be called the diameter of the circle. Very much true. That is what is the definition of the diameter. So I'm going to mark this statement also as true. Let's try to get rid of this. Okay, let's try to get rid of this as well. Now, statement number 5. Sector is a region between the chord and its corresponding arc. So let's try to visualize this. So first of all, let's draw a circle. Oops. First of all, let's draw a circle. This is a circle. Now we need a chord. Okay. So let's try to draw a chord. What is the chord? Chord is a line segment which connects any 2 points of the circle. So this is my chord. I have connected them. Now let's read what it says. Sector is the region between the chord. So this is the chord, between the chord and its corresponding arc. This is the arc. So if I want to use a highlighter, so if this is the arc, and then the region between uh, the chord and the arc is this green one. Okay, is this the definition of a sector? No, that is absolutely false. This is in fact called the segment. I'm going to write here. This is called as a segment. Okay, in fact this is called as a minor segment. Okay, and this one is called as a major segment. So this is a definition of a segment, not a sector. What is a sector? Okay, let's quickly see what is a sector. So okay, if this is the center of the circle, and if I try to draw these two lines connecting the center to the end points of the chord. Okay, basically it's the radius. So from the center you draw a radius to one endpoint, from this center you draw a radius to another endpoint, then this whole region will be called as a sector. Okay, that is the definition of sector. So sector involves the radius, the two radius from the center to the endpoint of the chords. So that is not what is asked in the statement. So we are going to make it false. Okay. And now coming to the last statement of this true and false series, a circle is a plane figure. So as you can see here, is circle a plane figure? No. A plane figure is a figure which we will make using straight lines. So a rectangle or a square, okay, or a triangle. These are all called plane figures because they consist of straight lines. However, if you look at this circle, circle is in fact the very opposite of straight lines. It's a curved continuous figure. So circle is a plane figure will be a false statement. Okay. So in this way we have completed 6 statements of true and false.